Hi, my name is Heng Jia. My student ID is CST2104280. My topic of this video presentation is concept of integration. This video was divided into 5 parts, which are the definition of definite integrals, Riemann sum, area of n rectangles, limit approach infinity, and finally conclusion. So, without further delay, we will now dive into the concept of definite integrals. This is the way how we write a definite integrals. This symbol is somehow a S symbol that elongated vertically, and this symbol representing the limits of sum. This is because integral is a limit of sum when x approaches infinity in definite integrals. In this notation, fx is called as integral function, while a is the lower limit and b is the upper limit of the integral. Then dx is representing the independent variable of x, which indicates the small change of x-axis. A definite integral have a condition that a function have a closed interval between a and b. Since it is a continuous, then it is also a definite integrable throughout the graph. A definite integral is a continuous and integrable. Therefore, we could apply the definition of integrals and the concept of Riemann sum to determine the area under the curve and to evaluate the integrals. So, what is Riemann sum? Riemann sum is an approximation of total area of a number of rectangles as I goes from 1 or 0 to n. The area can be calculated by dividing a graph into n numbers of subintervals from point A to point B. Delta x representing the small change of width of each rectangle. So it is equal to b minus a and divided by n. And n is the amount of small rectangle, which is an unknown variable. xi in this notation is representing the width of the next rectangle plus all of the width of rectangle in front of them, while the arbitrary point will pick between each of the subinterval of xi minus 1 to xi as the sample point of the intervals. Then, to find the area of each rectangle, we can just simply take the height of the rectangle of arbitrary point, then multiply to the width of delta x. I will use this graph as example. This is a x cubed graph. Since we have to find the area under the curve in closed interval from 0 to 2, so we can divide the graph into n parts of equal subinterval of each rectangle shaped from point A to point B. Actually, there are two ways to identify the graph, which is inscribed polygon and circumscribed polygon. The difference between these two graphs is that inscribed polygon is the sum of the area of polygon as I goes from 0 to n, while circumscribed polygon goes from 1 to n. This is because the x in inscribed polygon was counted from 0, while circumscribed was counted from x1. Actually, both are then resulting quite accurate result, but inscribed polygon are more preferable since it is convenient to use for more complicated questions as it is more precise. After we got the area of each rectangle, we now have to determine the area of n rectangles. By applying the sigma as sum of the areas, as I goes from 1 to n with the area of each rectangle that we found just now. Do take note that you may need to memorize or understand the concept of these sum formulas to ease you in sigma calculation. And so we could get the area under the curve But this is still not the end. We still have to determine the limits when n approach to infinity. This is because the numbers of rectangles are approaching to infinity since it is approximation under the curve, so we have to calculate the n to infinity. So as conclusion, if the limit of Riemann's sum is exists, therefore it can be represented by the definite integral of fx from a to b. This is because the limit of Riemann's sum and the definite integral of fx cover the same area under the curve. So in this case, the integral is an area. But do be careful that the graph which below the x-axis should be negative at a certain point, as it is a non-positive area. So that's all for my presentation. Thanks for listening. Have a nice day.